Hello student, the last type of work is zero work. Already we had discussed about the positive work and negative work, but this is a zero work. So remember the formula that says that work done is product of force with displacement. Now, this work done can acquire zero values with three conditions. First, when external force is zero. Obviously, when this external force will acquire zero value, work done also becomes zero. Second case, when displacement is zero. For example, if this is a wall and if I will apply a huge force on it, this is a wall, and if I will apply a huge amount of force, no displacement take place for this wall. This wall will not move from its position. So what we will say, that displacement is zero. So if displacement will zero, the work done will also zero. And the third case, and most important, that if force and displacement are perpendicular to each other. If force and displacement are perpendicular to each other. But how we can say that if they are perpendicular, then work done is zero? So I want to reveal a very important concept of work done. I will modify the formula that what you have studied. We know that work done is force into displacement. But as you will go in 11th class, what you will study, that force is not just work done is not just force into displacement. It is force, displacement, and another term appear, that is cos theta. This is a higher or upgraded version of the work done, that force into displacement into cos theta. What it signifies? Just see. If this is a block, this is force and this is displacement. So now we can see the angle between them is zero. This is force and this is displacement, and the angle between them is zero, and we obtain a positive work done. But this is not the case every time happens. Sometime this is a block, this is force, and this is displacement. Again, an angle theta exists between the force and the displacement. So we will just consider the component of force that is along the displacement. Just listen it very carefully. We will just consider the component of force along the displacement. And you will study in higher classes that the component along S is F cos theta. The component of force along displacement is F cos theta. So the work done now becomes F, S and cos theta. So if theta will become 90 degree, when it will become 90 degree? When force and displacement are perpendicular to each other. I told you that for zero work, the force, if this is force and this is displacement, and angle between them is 90 degree. So if theta is 90 degree, then work done as per our new formula F dot S cos, the angle will become 90 degree, and we know cos 90 is 0, so work done will be also 0. So just remember this fact that whenever force and displacement are perpendicular to each other, then work done is 0. I will give you some example. Now consider a coolie carrying a block on his head, and he is just moving in this direction, and after some time he is supposed to raise his hand to hold the block. Okay, so if he reaches to this position, now just look at the displacement. So this is the direction of displacement, and the force on this block is towards the earth, that is the gravitational force. We know it, mg, 9th class में पढ़ चुके हम लोग, that this is the direction of displacement and the force on the block is mg. So now the two are perpendicular to each other. The force mg is towards the earth and the displacement is in this direction, and they are perpendicular to each other. Then what we will say, that work done by this man is 0. Another example, a very interesting example. We all know that sun is situated at the center and all the planets move around it. Not in circular orbit, they are in elliptical orbit, but we can consider that they are moving in circular orbit. So whenever they move at any instant, suppose this is the direction of displacement, as they are moving in this clockwise direction, suppose this is the direction of displacement at any instant. Instant means किसी भी time पर ये है उसका displacement, and if they are moving in this circular orbit, a force does always act towards the center. This concept already you had studied in class 9th, that if a particle is performing a circular motion, so every time the direction of displacement is along the tangent. Remember student, that if a particle is performing a circular motion, that at any instant a tangent drawn at the point gives you the direction of displacement, and to complete this circular motion, a force that always acts towards the center of the earth. So what we can see, that this is the direction of displacement, and every time the force is along the center of the circle. So the angle between the force and the displacement is 0. So remember the fact, remember the concept, that every particle that is performing a circular motion, the work done to perform that circular motion is always 0, as the angle between displacement and the force, this is force, always towards the center of the earth. If particle at any instant reaches at this point, so this is the direction of displacement along the tangent, and this is the direction of force towards the center. If particle is here, so this is the direction of displacement and this is the force. So every time what we will see, that this is displacement, this is force. Angle between them is 90 degree, work done is 0. Here this is the displacement and this is force. Angle between them is 90 degree, work done is 0. So remember it, that whenever force and displacement are perpendicular to each other, work done due to this force is always 0. This is example. A load of 100 kg is pulled by 5 meter. So this is the mass of the load and it is pulled by a distance or displacement of 5 meter, then we have to calculate the work done. We have to calculate the work done. A load of 100 kg. So this is the mass 100 kg, and it is displaced by S is 5 meter, and we have to calculate the work done. So let's see. According to our formula, work done is force into displacement. Now force, as we know, that force is mg, and this displacement is as usual S. Mass is given, that is 100. Value of g, we all know, that is 9.8, and displacement is also given 5. So 100 into 9.8 into 5, and this is equals to, I think, 4900, and the unit of work is joule. So which force we are talking about? Which force we are talking about? As the work, the load is having some mass, so we have to work against its mass. कोई हल्का ऑब्जेक्ट है, उसे चलाने के लिए हमें वर्क कम करना पड़ेगा. कोई भारी ऑब्जेक्ट है, वर्क ज्यादा करना पड़ेगा. So we can say that we are doing the work against that gravitational force. That's why we had used this force is equals to m into g. Consider another example. A car weighing 1500 kg. So obviously mass of the car is 1500 kg. No need to convert the unit, as kg is SI unit, and it is traveling at a speed of 25 meter per second. Stops at a distance of 50 meter with uniform retardation. Retardation is negative acceleration, and it is moving with a speed of 25 meter per second. So initial velocity is 25 meter per second, and it stops. So whenever it stops, its final velocity is 0. And as it is moving with uniform retardation, we can use the equation of motion. Remember that we can use equation of motion only when there is uniform constant acceleration retardation. Uniform acceleration, constant acceleration, uniform retardation, and constant retardation. Then only we can use that three equation of motion. And here the displacement is 50 meter. We have to calculate the force on it, force exerted on the body. Okay, let's calculate the work done also. Find work done. Just add here that find work done also. So first we will calculate the force. Now remember that force is equals to mass into acceleration. We have to calculate force. Mass is given. Mass is given. We are supposed to calculate this acceleration. Now as we can use the three equation of motion, remember the third equation of motion, that is v square is equals to u square plus 2as plus 2s, but here I had mentioned negative sign. Why negative? Because it is a retardation. In case of retardation, the acceleration becomes negative. Actually the formula is v square is equals to u square plus 2as, but I am mentioning it negative because acceleration is always negative. Not negative. In case of retardation, acceleration is negative. Now v is 0, u is 25, so 25 is square, 2, s is 50, so 2 into 50 into a. So value of acceleration is 625 upon 100. So 6.25 meter per second square. This is 625, square is 625 divided by 100, we will get 6.25. And this is a negative acceleration. This is a negative acceleration as already mentioned in the question, that with uniform retardation. Retardation means acceleration acquires a negative sign. Now we can calculate the force. As force is equals to mass into acceleration. Mass is given 1500 and acceleration is 6.25. So we can calculate the force. And the work done also, as work done is equals to force into displacement. Force into displacement. So force we can calculate from here, and displacement is 50 meter. So we can multiply and get the answer. I will give you a sheet on this concept and you will solve in your fair notebook. Thank you, students.